of what you just said.
No one wants to hear that.
Yeah,
Is a Jew.
you don't want to hear that. Yeah. Not out of my mouth like that in that context.
Well, what was it that you said again?
I was just talking about his family history. It's very cool. Okay, today we're going to do what we call one-step equations. So essentially this whole unit is going to be about having something that's unknown. Typically in math, whatever's unknown is called x. And you want to try to find the value that makes that equation work. And that's all we're doing. And today should only be one step to figure it out. In the future, there'll be 2 steps, 3 steps, and there'll be multiple steps to figuring out what x is. Yes, sir.
This unit are we working on binomials?
We will, yeah. We'll have binomials. We'll probably have trinomials. Like it will get bigger, and it'll start small. Like I said, like it's going to start off not crazy, and then it's going to get harder. To be able to do this, I'm just going to write some things at the top. You're going to do opposite operations. Okay, so you're going to do the opposite of whatever you have. So, for instance, if you have addition, what's the opposite of addition? Subtraction. And vice versa, right? Like the opposite of subtraction is addition. The other one we're going to see is multiplication. What's the opposite of multiplication?
Let's go subtractication.
Subtractication. You got it. Somebody said it over there. Yeah. Divide. Division. I had to think really hard about how to spell division. That was a struggle for me. It's been a long weekend. And we won't do too much up, but the opposite of square rooting would be squaring. And we won't get too much into that because that's exponents. But we will eventually see that stuff probably. The 2 big ones are the opposite of addition is subtraction and vice versa. The opposite of multiplication is division and vice versa. We want to do the opposite of things in this unit. So for instance, when you look at this first question, it says m plus 5 equals 9. Our goal is to figure out what value of m would actually make that true. And yeah, like you can sometimes look at them, especially easier ones, and just know. You could look at it and be like, oh, it's 4. It's 4 plus 5 is 9. So you could do it in your head. But the idea for today is to build up this concept of opposite operations and solving for m algebraically. So to solve for m means to get m by itself, which means I want to move this 5 to the other side of the equal sign. You do that by doing opposite operations. So what is the opposite of plus 5? Subtract 5. And if you do something to one side, you do it to the other side. The reason we want to do opposite operations is because when you do the opposite of something, it'll get rid of that thing. The 5 will now be gone on the left side. And the only thing left on the left side would be m. Yeah. Yes, sir.
I'll be back in a while.
On the right side, you now have 9 subtract 5, which would equal 4, getting us our answer of m equals 4. I know that there'll be questions that you could just do. You could look at it and ring it off. And I get that. And I want you to try to do these opposite operations because the questions will get too hard to do in your head. So you want to build that skill before we get to those harder questions. Cool. If we look at B, we have b plus negative 4. When I see 2 symbols like that, I like to rewrite it as one symbol. So if I have plus and a negative, it would turn into a negative. So a positive and a negative turns negative. Then I can do opposite operations to get the letter B by itself. This is B minus 4, or subtract 4. The opposite of subtract is adding. So I want to do the opposite of subtract 4. I want to add 4. And what I do to one side, I do to the other side. What I'm doing by adding 4 is I'm moving that 4 to the other side. Right? That's what's happening, is I'm moving it to the other side of the equal sign. These 4s will cancel out. I've moved it to the other side, so I now have b on the left side equals negative 12 plus 4 is negative 8. So if you put that in your calculator, that would give you your final answer. Opposite operations. Not crazy, right?
I got the right answer.
If we look at C, this is h minus 7 equals negative 9. We want to move that 7 to the other side by using opposite operations. The opposite of subtraction would be adding 7. What you do to one side, you do to the other. Those 7s will cancel out. I now have h on the left side equals negative 9 plus 7. If you put in your calculator, it equals negative 2. Cool. Let's go up here. You have 3 questions there on the right. Actually, I'll do these ones with you still. This one's a little different because of where things are. Okay, this time k is on the right side of the equal sign. So I want to move this to the other side of the equal sign so that k is by itself. We have that situation where there's 2 signs again. So if you have plus minus 5, we can rewrite that to be k minus 5. A positive and a negative becomes a negative. Now my goal is to get k by itself. So how can I move that 5 to the other side? Yes, sir. The opposite of minus 5 is add 5. So I'm going to add 5 to both sides. So these 5s will cancel each other out. I now have negative 11 plus 5 is negative 6. And I still have k on the right side. So my answer is k equals negative 6. Thank you. Too loud. E. Okay, we have that double symbol thing going again, right? We have a minus and a minus. 2 negatives become perfect. So this is actually a plus 20 equals 9. Our goal is to move that 20 to the other side. We do so using opposite operations. So to move that 20 to the other side, you're going to subtract 20. The opposite of adding is subtracting. That leaves me with a equals negative 11. F. F has that double symbol again. So the first thing I do is I recognize there's 2 negatives. 2 negatives become a positive. That means this is m plus 8 equals 17. If we want to move that 8 over, we do the opposite of adding 8. The opposite of adding 8 is subtracting 8. What you do to one side, you do to the other. So those 8s will cancel. I have an m on the left. 17 minus 8 is 9. So that's how you move numbers from one side to the other, right? You opposite operation them. You have, let me see how many. Those 4. I want you to try to solve those 4 on your own. So I'll give you a minute or two here. You're just going to work through it on your own. And then I'll show you and see if you got the right answer or not. So you can see if your answer is right or wrong. This one, you should have subtracted 14 to the other side. When you subtracted 14, they would cancel out, and you'd be left with W equals negative 22. For H, the first thing I would do is I'd see that there's a double negative. See how it's like a minus negative 15, and I would change that to be plus 15. Then I would subtract 15 because that's the opposite of plus. Right? But I had to change those double negatives into a positive first so that I could move that 15 over. And that's probably the important part, is realizing that these two turn into a positive. Right? A negative and a negative turns positive. If you did that, 7 minus 15 would give you negative 8. This one. This one has a positive and a negative. That means it would be negative. Like that. The opposite of that subtract 1.1 would be to add 1.1. In your calculator, if you go minus or negative 2.3 plus 1.1, you should get negative 1.2. I think. The last one. Hey, get out of here, Luke. I saw you doing over there, and I was like, nobody even said anything to you. If you look at J, you got that positive negative again. So it'd be Z minus 13.2 equals negative 27.9. Okay, so recognizing that positive negative became a negative. Then I can do my opposite operation. I can add 13.2. Gives me Z equals negative 14.7. Yeah. Yep. Just give me 1 second. It's the next one started. Okay. Checking your work. So what we're doing is we're taking equations, like this one right here, and then we're getting solutions. What that solution means is that if you took your answer, you should be able to test that answer by putting it back into the original equation and seeing if it works. So if you went back to the question and you changed x to be negative 9, would both sides of the equal sign actually equal each other? And that's how you can check your work for all of your questions, right? Change the letter to be the number that you said it is. In this case, I am saying x is negative 9. So if I change x to be negative 9, do both sides actually equal each other? If you go negative 9 plus 15, it equals positive 6, not negative 6, which means this is the wrong answer. Because the two sides didn't equal each other. We typically call that verifying your solution or verifying your answer. If the two sides are equal, you have the right answer. If the two sides are not equal, you have the wrong answer, which means you made a mistake somewhere. If you look at the question to the right, is another example of that. So we could check to see if that answer is right or wrong. My computer just froze. So we could check our answers. Here's another example. We could take this value. We could say, all right, if D equals negative 2, let's test to see if it really works by changing D to be negative 2. If you try that, negative 2 plus 16 is 14. 14 does equal 14. That is the correct answer. So you can verify or check all of your answers through this whole first probably 3 days, which is kind of nice. Okay, we're going to continue trying to solve equations. We're going to continue doing so by doing opposite operations. These questions are slightly different because it's not obvious the operation that's happening. So when you see something like this, if there's no symbol in between the 3 and the m, that means multiply. All right, no symbol means multiply. So this question, if you're reading it, would read 3 times m equals 21. To solve for m, we have to move that 3 to the other side. The opposite of multiply is divide by 3. And that's how we show divide, with like a little fraction symbol. Yeah. And if you do that to one side, you do it to the other side. So that you get m equals 21 divided by 3, which is 7. So we're still doing opposite operations. It's just now we're doing the opposite of multiplication and the opposite of division. So if you look at B, reading this means 4 multiplied by B. If we want to move that 4, the opposite of multiply is divide. So I need to divide that 4 to the other side. We divide it by making that like little fraction symbol, right? That means divide. These 4s will cancel out. B is the only thing that's left. On the other side, in my calculator, I would go negative 20 divided by 4 to get negative 5. Right? We're still doing opposite operations. It's just now we're doing the opposites or multiplies and divides. If you look down at C, this means negative 8 times n. Right? If there's nothing there, it's times. The opposite of times, or the opposite of multiplication, is dividing by negative 8. What you do to one side, you do to the other. Those negative 8s will cancel each other out. That means I have n equals negative 40 divided by negative 8 is positive 5 in your calculator. Opposite operations. If there's nothing in between the letter and the number, it means multiply. Sometimes I say the word times instead of multiply. Those mean the same thing. Right? Times and multiply, same word.
Well, that's something you learn in grade 3.
Yeah, it's just sometimes we forget what each word means. We're going to go up here. For D, this is -9 times M equals 63. The opposite of multiplication is division. This leaves me with M equals -7.
How?
So we divided -9, and then in our calculator, somebody said how or why. So in my calculator, I put 63. That means divided by, and then -9. And that's how I'm getting -7. Is I'm putting that in my calculator. This one. If you were to read what that question means, this is H divided by 2. That's what that means, divided by 2. The opposite of divide is multiply. So to move that 2, I need to multiply both sides by 2. I do multiplication with a little dot like that. Those 2's would cancel each other out. So I have H equals 16 multiplied by 2 is 32.
What if you have that, but the letter beside it? So it's like 2 over 5 times t.
Like on the next page. Let me get to that one. I'll do this one quick. So this one is K divided by 6. The opposite of divided by is multiplication. So I'm going to multiply both sides by 6 to give me K equals 30. And then I'm going to fast forward to the one you just asked, Jaden. Right? Opposite operations. I'm going to fast forward to like this one, H. Is that the one you're on, Jaden? Yeah. Okay. This one. This one, you've got 2 things going on. Okay, this is the same thing as saying 5 times n divided by 8. Okay, that's the same idea. And if you can change this to be that, then we can use our same trick to get n by itself. So you're going to have to multiply to get rid of the 8, because that's the opposite of divide by 8. And then you're going to divide to get rid of the 5, because that's the opposite of multiply. So I'll actually do it in 2 steps. I'll show you what I mean. So I churn that fraction to be 5 times n divided by 8. I'm going to move the 8 first. The opposite of dividing by 8 would be multiplying by 8. So these 8's will cancel out. And I have 5n equals 40 times 8 is 320. I'll give you a second to write that down and to ask if that makes sense. Notice how I moved the 8 over by multiplying. And now I still have that 5, right? So how can I move the 5 to the other side?
Divide by 5.
Divide by 5, right? Because this is 5 multiplied by n. The opposite of multiply is divide. So now I need to divide both sides by 5. That's how I like to tackle those questions. It helps us avoid using fractions, which is always a positive. You should get What'd you get? 64? Sounds right to me. So when you get those weird fractiony ones, that's how we like to tackle it. Move one number over, move the other number over. I'll do one more with you. So if we slide over and up to this one, I would rewrite that so that I don't have those fractions out front. So I'd rewrite it like this: negative 4a divided by 3 equals 24. By rewriting it, it allows me to kind of easily see I need to move this over first, this over second. So how could I move the divide by 3? The opposite of divide by 3 would be multiply by 3. Perfect. So I'm going to multiply both sides by 3. I still have that negative 4 over there. 24 times 3 is 72. Yeah, Miles.
72 divided 3 equals 24.
We want to do 72 divided by what number are we trying to move over? So we want to do 72 divided by 4. So we're going to divide both sides, and it's negative 4. So we're dividing both sides by negative 4. What do you get in your calculator when you do that, Miles?
Minus 18.
Perfect. Thank you, sir.
How long has this been in your class?
Long time. Again, we're doing opposite operations, but now it's multiplication division opposites. So when you get these types of questions, your goal is to turn that into a mathematical equation. The way you do it is by building it as you read it. So for instance, when they say a number, that means n. You don't know what the number is, so you put the letter n. If you want to put x instead, you can put that as well. So a number subtracted by, so minus 35, and then is 98. Is means equals 98. So I've tried to color code it so you can kind of see how to build it, right? A number subtracted by 35 is 98. From there, you can solve it by doing opposite operations. So for this question, I would have to add 35 because the opposite of subtracting is adding. This means it gives me n equals, what'd you get, 133? That means that number is 133. So build the equation, solve the equation. And you build by reading. Sometimes they use words we haven't seen in a long time. So for instance, in B, the difference means subtraction. Yeah, so difference is subtracting. So the difference of a number, so we put n here, and negative 23 goes right there, is 35. So equals 35. That's a hard one to set up. So they said the difference. That tells me it's a subtraction question. Just give me 1 second. The difference of a number and negative 23 is 35. What's your question, Mom? Oh, you want help with a calculator? Okay, give me 1 second. I'll be right there. I'll come right there. I'll check. Yep.
Okay, negative minus a negative equals positive, right?
Right. So this turns into n plus 23. equals 35. So remember, we have to deal with those double symbols to make it a positive. Then the opposite of plus 23 would be minus 23, which means n equals 12. The word problems are easily going to be the hardest part for us because you have to be able to set it up and then solve it. So like that's a challenge, right? This one. Build it as you read it. Add number n decreased by means subtract 45 is negative 78 equals negative 78. Build it as you read it. To solve, you do opposite operations. The opposite of subtract 45 would be add 45. Meaning n equals negative 33 again. Like that. Yep. Yep. 1121. Did you not get that? Did you put the negative symbol? Okay, if you look at D, build it as you read it. A number n. Increased by means add. Negative 45 is means equals 77. When we get those double symbols, combine them to become one symbol. So this really means n minus 45 equals 77. Right? That positive and negative became a negative. We then can do opposite operations. The opposite of subtraction is addition. We're going to add 45 to both sides. That gives me n equals, oh no, 122? I lied. What is it?
152.
No, it's 122? Didn't see this was the last one. This, reading it as we go, 6 times. So 6 times a number n is negative 96. Right? Set up the equation, then solve the equation. The opposite of timesing is dividing. So we divide both sides by 6. Those will cancel. I'm left with n equals negative 16, I think. Yeah, thank you. Okay, set it up, solve it with opposite operations. Please practice.